This is Pre-Calculus Onramps Homework 3.31. I'm going to do one question from each section. Let me try 4. The value of $1,500 stainless steel refrigerator depreciates by 10% every 5 years. So depreciation means subtract. So I'm going to subtract 10%. It's 1 minus the rate, 1 minus the depreciation rate. Well, I have to write that as a number. So it's going to be 10% divided by 100, which is 0.10. 1 minus 0.1 or 0.10, 0.10 is 0.9. So this is going to be 1,500 times 1 minus 10% divided by 100, 1 minus 0.10, which is 0.9. And then it's going to be t, and the k value, because remember what this is, a times b to the kt. K is once every 5 years, so 1 over 5. So 1 over 5 times t is t over 5. And so that's the function for number 4. Next one. In exercise 5 to 13, write an exponential function, a times bt, passing through the given points. Sketch a graph of your function. Well, I'm going to use, I'll show you how to do this on a TI-84, and then I will show you how to do it on Desmos. I'm only show on the TI-84 once. I'm going to press Stat, and then I'm going to go Enter for Edit. I'm going to put in some values. I'll do this one first. 0, 6, 0 is the x value, 6 is the y value, 3 is the x value, 750 is the y value. So I have that. 0, 6, that's the first point. 3, 750 is the second point. Then I'm going to press Stat again. I'm going to arrow over to Calc, hit Enter. Whoops. What did I do wrong there? Stat, and I'm going to go over to Calc, and then I've got to scroll down to Exponential Regression. It's item number 10. Then I'll hit Enter. And my X list is L1. That was the L1 variables were the X's. The L2 variables were the Y's. And then down to Calculate, Enter, and I get A is 6 and B is 5. So the function is 6 times 5 to the X. 6 times 5 raised to the X. And f of t equals 6 times 5 to the X. Sketch the graph of the function. Well, this is going to pass through 0, 6, and 1, 2, 3, 750, way up here, and it's going to approach 0, so it's going to look something like that. So that's it. The rest of these I will work on Desmos. Let me do one more, and I guess -1 5/3 and 245. I'm going to do this one on Desmos. I'm going to put in a table. You can do this on the TI. So it's -1 5/3. Whoops. And then 245. And on Desmos, I press this line with the dots around it, and I want exponential regression, and it shows me 5 times 3 to the x. Y equals 5 times 3 to the x. And it passes through -1 5/3, which is right there, and it passes through 245. How do I find out? Now it's a exponential growth. So how do I find out where it crosses the x-axis? Well, I set x equals 0, so y equals 5 times 3 to the 0, which is 5 times 1. Any number to the 0 is 1, which is 5. So when x is 0, y is 5, and as you can see on the Desmos graph, it's right there. So I can graph that. I go 1, 2, 3, 4, 5. It approaches 0. I have -1 and 5/3, which is 1.67, somewhere around there, and I guess that's good enough. And I go up like that. So there's that one. All right, next section. In exercise 14 to 20, give both the exact without calculator and approximate with calculator answers. And again, it's going to be this same f of x equals a times b to the kt. So I'm going to do the one with a car. A car purchased for $25,700 depreciates at a constant rate of 3%. That means it's subtracted. 3% is 0.03. It's 1 minus 0.03. So it's going to be 0.97. The initial amount is 25,700. And then it's going to be each year, so it's just going to be t. K is just 1, so it's just going to be to the t power. Now I want to know what it will take for the car to be worth $10,000. So I want to know when it's going to be worth $10,000. So I'm not doing any of these other ones right now. I'm just going to use this room to write my answer. So I'm going to do 10,000 divided by 25,700. I'll cancel out 2 zeros, so it's going to be 100 divided by 257 equals 0.97 to the t. Now, I need something so I can get that t not to be a power. Log to the rescue. So you can use any base log you want. I'm going to use natural log. Natural log 100 divided by 257 equals natural log of 0.9 to the t. And then I could put that t out in front, equals t times natural log of 0.9. And so then it's going to be the natural log of 100 divided by 257 divided by log, natural log of 0.9, and that equals t. And you can do that on your TI-84. I'm going to do it on my Desmos. Natural log of 100 divided by 257 divided by natural log 0.97 equals approximately 30.989, approximately 31 years. 30.989, approximately 31 years. And I think the answer that is given in the homework is log base 10 of 100 divided by 25 divided by log base 10 of 97 over 100. Let's see. I think it's 970 over 100. Wait a minute. Oh, not 25, 257. And then it's 97 over 100, which is the same thing, 30.989 or 31 years approximately. So there's that one. Now one more. It asks, wait a minute. Oh, I did that calculator one already. Then it asks me to sketch a graph of the function. I'm going to do 26. Remember, an exponential function crosses at 0, 1. It approaches y equals 0, and it goes up. That's the growth. Now this one's a decay. So a decay one crosses there, and it goes down, and it approaches y equals 0, like that. So this one is multiplied by 3 and subtract 4. So the asymptote is going to go down 1, 2, 3, 4. So instead of y is 0, the asymptote is going to be y equals -4. And what does this say? It says identify key coordinate points, identify asymptotes. I've done that. I'll sketch the graph in a second. I can find where when x is 0, what is y going to be? 3 times 1/2 to the 0 minus 4 equals 3 times anything to the 0 power is 1. 3 times 1 is 3 minus 4 is -1. So it's 0. It's going to be -1. Let me get rid of this other one, this decay, so it's not messing us up. So at 0, it's going to be -1. And then what about when y is 0? When y is 0, this is going to be 0 equals 3 times 1/2 to the x power minus 4. I'll add 4 to both sides. 4, I'll divide by 3. 4/3 equals 1/2 to the x power. I'll take the natural log of both sides. Natural log of 4/3 equals natural log of 1/2 to the x equals x natural log of 1/2. I can take the exponent, put it out in front. And then if I take natural log of 4/3 and divide natural log of 1/2, that equals x. And if if I do that on Desmos, natural log, I can use log to any base. Natural log of 4/3 divided by natural log, was it of 1/2? 1/2, negative 0.415, approximately negative 0.42. So when y is 0, x is, x is negative 0.42, somewhere around there. So I have key points of 0, -1, and negative 0.42, 0. Those are some key points where it crosses the x and y axis, and it approaches there. So I just go whoop, like that. So there's my graph right there. And I think that's it for that worksheet. Onramps, homework 3.3.1.